consistent.
So everyone beat? Happy with beat? Like beat? 320 amps, 20 more amps, right?
You gotta have 3
Good. So let's put those two curves together. Here's our 320 amp at the rated output. Yeah, 320 is higher at the rated output. It's 6,000 alternator RPM, or 3,000 engine RPM. How often do you think your truck gets up to 3,000 RPM?
Your red line's 2,000. So it'll never get there, obviously.
They'll never get there. So what you want to look for when you're looking at alternator output, you want to see what the idle output, just like Dan was saying. Everybody wants to know what your output at idle is. Well, that 300 amp alternator output's 180. That's the one you want to get. Because what does your truck do when it leaves the firehouse? It runs like all hell down the road, gets to the scene, and then idles. Unless they got a pumper or something else that kicks up the engine RPM a little bit, but they're not going to see that higher RPM. They're only going to see that driving down the highway and gunning. So in a lot of cases, when you're seeing a complaint of a vehicle not having enough power, of batteries not getting charged up enough, and you're wondering why, well, we just spec'd this new alternator, it's supposed to be this much output. Well, in reality, you're only going to see this lower number for most of that vehicle's life. So you want to have one that has that higher output coming through. Now, we have voltage versus current. I have a 300 amp alternator at 6,000 RPM, alternator RPM, max output. My regulator set point is 14.5. My first condition, I have 14.4 volts at the batteries and 300 amps. Am I good, overload, or faulty? Good. Yeah, I'm good. System loads are with an alternator capacity. That difference between my set point and my voltage, probably voltage drop in my cable. My next case, I have 13.8 volts now, but I still have 300 amps. What's happening here? Am I good, overload, or faulty? I'm actually overloaded at this point. The alternator is outputting as much current as it possibly can, but I still can't meet all the loads that the vehicle is outputting. So my voltage is going to start sagging in the system, because now I have to draw current out of the batteries to charge the system.
But the charge system to maintain the vehicle load.
Or to maintain the loads. My last one here, I've got 13.2 volts, 250 amps. What happened here? I'm faulty now. So, if I have 6 phases in the unit of 300 amps, it means I have 50 amps per phase. So if the unit was supposed to output 300, but I'm down to 250, hey, I just figured out, I have a bad diode. I lost 50 amps. And you're going to lose that percentage throughout the whole curve of the unit. So you don't necessarily have to be at full output to realize that you're missing that. So if you know the alternator speed, you know what it's supposed to be outputting, you can figure out that 1/6 of the phase output to figure out what, then you have a drop in the system going on. Now our charging system. We have our alternator, our batteries, our wiring, and our loads. Right? Because we're a whole system, everybody's working together. I got my alternator, I got my starter, I got my batteries, got all my lights, my nice fancy lights and horns and everything going on. Here I have some schematics and components. So when we're looking at our wiring schematics of our alternators, here I have my regulator, here I have my alternator. I have a switch, I have my batteries. I have a fuse. I have a capacitor back there in the alternator. Got my lamp. Got an LED showing. Got my diodes showing. My resistance. My load of the vehicle. I have my inductors. And I have my relays. So as we're looking through, whenever you're looking at a schematic, you can tell everybody draws these based on a similar system. So here I have a C680 wiring schematic. So now I don't have a troubleshooting guide. I got a wiring schematic. Well, I know I need a couple of things for this to work. I need my battery. So where's my battery wiring? Well, here's my battery here. There's my ground. So my battery goes here, goes in there, comes out here, goes back to ground. I have my ignition coming into my alternator, into the regulator, through the ignition switch, comes out, grounds out to the alternator. I have my power to my regulator. So the regulator is receiving its power from inside. Here's my connector coming into the regulator from the alternator. I have my B plus, and I have my ground going into it. So if I'm testing a regulator or a charging system that isn't working, I can unplug that, test those two pins, and see if I'm getting battery and ground coming into there. If I'm not getting battery and ground coming into here, but I know I have battery here and I know I have ground there, I just solved where my problem is. I just figured out my troubleshooting problem. I also have my field coil here. So coming in, one end of the field coil, and I got the other. Sometimes the field coil is provided power all the time, so it goes through the B plus. Sometimes it's provided ground all the time. It just depends on how they wired up the circuit going through. Here I have my AC sense / diode. So this is where my P, my AC P or R terminal is getting its feed. So I have one of the stators here, our Delta 1 stator. Its tap is coming in, going into the regulator. That's how it picks up its RPM and rotation going through the circuit. And some units I have a diode trio. Now what does the diode trio do for me? It provides a self-exciting circuit into the alternator. All those old alternators that are one-wire hookups, just put the B plus cable to it and it'll work all by its own. They have a diode trio somewhere in there. Diode trio, as the unit spins, outputs a voltage back into the regulator and turns it on. It acts as the ignition switch for the unit going through. Not all units are going to have a dual diode trio. Some will require to have an ignition signal coming in to turn them on. Here I have a C510. So I have my alternator, I have my rectifier, got my regulator, got my ignition switch, my load, my battery, got my field positive, field negative coming out, going into the connector, got my phase wires coming out, going there, got my phase tap. Same circuits, just different way of doing them. Here I have my C527, 531 units. Here, you see that there's two connectors. Here's my temp sense, the J1939 cables. Coming out and going to my battery temp sense and ignition. And my connection is going into the alternator. See here I have a field negative, but the field is always getting positive from the battery. So if I gotta test that field coil, I do my resistance test, I have to do it between that pin and the B plus to figure out. Whereas on the other ones, if I have both field wires coming out, I can test them right through the harness, which is one of them. Another important thing about our wiring and our cabling and our schematics is stacking order. But you want to always make sure, you gotta remember that current is flowing through that cable and then through all the other washers and copper rings and lock washers that you put on there. So if you mess up your stacking order, right, because I have my lock washers, my flat washers, and my output terminal here, if you mess that up, you now have that voltage has to go through all those terminal leads. What you just created, if you stack them wrong, is voltage drop. Because now your current has to get through more metal, has to get through more resistance going through. Another is that if you have multiple studs going to, multiple outputs going to a single stud, you want to make sure that your largest consumer is the closest to the output. You don't want to put it below a lower one, because otherwise all of your current has to get through that little wire. It's real common, guys that put aftermarket radios and stereos and put the amplifier in their trunk, go and start adding cables to their battery terminals. They don't realize that they put the terminal going to their amplifier down first, then they put the cable that goes down to their starter on. Then they wonder why their truck doesn't start in the middle of winter. Think maybe they left the radio on. Turns out no.
Seen it many a time on starter stuff where they put all the accessory cables on first, and they put the battery cable on top of it, and then the solenoid fries out, and you pull everything apart, and you see all the threads on that brass stud melted.
If you created an issue with that stacking order. So it becomes important when you're going through, changing out starter, changing out cables, changing out batteries, that you put everything stacked back in correctly on those terminals. Now for troubleshooting, this is where we can go to our the second handout. So this is one of our troubleshooting guides for our alternators. First step is we're going to check battery condition, and power to our regulator, our field coil, magnetism, the AC sense and diode. Now, I used to always show it like this. That made things a little bit easier. So, here, I'm checking for ignition to the ignition terminal of the regulator. Checking it between ground, checking for my voltage. I have my voltage there. I know that I've ruled out the vehicle harness at that point. Here I'm checking my V plus and ground. If I don't have V plus at that terminal, do I have a charging system problem? Or do I have a cabling problem? I have a cabling problem. I should always have V plus there. You know? Did maybe the master disconnect switch break? Did a cable come loose or corrode out? Going through. Another thing is to check between your battery, what's your battery voltage and what your voltage is there. But the first thing you did when you came up to a vehicle that wasn't charging, you checked the battery voltage. You went to the alternator, checked its voltage. Guess what you just did? Voltage drop testing. Take the two numbers, subtract them, the difference, that's your voltage drop. Going through. Now here, I'm checking internally with the alternator. We call out in our troubleshooting guides test harnesses. We made these to make it easier for guys to test our units, because all of our units are now using these round type connectors and pins. It's a little bit harder to get in there to test with your power, with your multimeter probes to get on there. So we made this harness. Now all the harness does is it acts as a breakout. So the same pins that are in the connector are the same pins on the harness. So even without the harness, you can still test all these circuits. Here, I'm checking between C and D. Well, my C and D are my V plus and my V minus. So I'm checking for power going into the regulator, coming through the alternator. Because I've already figured out that there's power and ground on this end. I've already checked those, I know it's there. If it isn't here, if it isn't in that connector, so we check our field coil and we check its resistance. Let's see if it'll carry voltage through itself, through the pin, and through the connection. Now, with these test harnesses, the regulator connection is not necessary. So you don't have to test with the regulator connected to the vehicle, to the harness while you're testing. At this point, we're testing the alternator to see if it's outputting. The regulators can only be tested on a no good alternator. Basically, if all the inputs going into the regulator are good and everything else on the vehicle is good, then you have a bad regulator. If we check at any point in doing this and you find that you have a failure of the alternator, then you know you don't necessarily have to change out the regulator on the vehicle. Now the next test here, what do you think we're doing? We're going between pin A and ground.
Can't go short?
Well, what I'm doing is I'm shorting the field to ground. Since the field is always getting power through the B+, while the key's on, I can do a significant magnetism test. What you're going to do is you're going to take the ground connection from the field, which is our F-, pin A, and we're going to connect it to ground. Now when you're doing this, you want to have a secure connection to this pin, and you want to have the spark happen out here. At the same time, you want to take a steel shaft, steel tool, hold it up to your pulley, and see if it pulls. If you don't get any magnetism, it doesn't pull, and you know that you've connected well to pin A and to ground, even though your field coil may have resistance checked good, it can't carry the current. So it's bad. If it does work, then you know it can carry the current as well as carry the voltage going through it. Now you only want to do this test momentarily. That's why I show it with a button. Jumper. You have the starter button that you get. Glows a little red when you make a good connection going through. I say to use that because then you can have one hand pressing the button, or you can have your chin press the button, or you can sit on the button, get it to work, connect in, and still have one hand free to hold the shaft. Generally don't put your fingers between the shaft and the unit because you'll hurt yourself. And also don't have the vehicle running when you do that. Don't know why I have to always say that, but I have to because there are people that have been on the, is going through that, is being fed through that we're going through. Here, when the battery isn't needed or the alternator, we subtract the battery voltage from one to the other. So I checked at the batteries, I checked at the alternator, take my two readings, that's my voltage drop going through the circuit. And there's some tools that make it easier to check voltage drop. The power probe hook here, it shows battery voltage all the time when you connect it to the battery. Then it'll show pin tip voltage. So if I take the tip voltage, subtract it from the battery voltage, I just figured out my voltage drop in that circuit. There's a couple of other tools that you can use. These are a set of leads called Load Pro. Some of you know it. What these are is basically a resistor on a switch. So if you connect up to a bat and connect it up into a circuit, you read full system voltage. You press the button and voltage drops, you know you have extra resistance in that circuit. That circuit can't carry the load that it's supposed to be designed for going through the circuit, going through it. Because just because you have full system voltage doesn't mean that there isn't a big resistor hiding out in that circuit. I have a couple of meters here. Manual arranging and an auto arranging one. I have them hooked up together. So I have this one reading voltage, this one reading resistance. Your meter, when you're doing resistance testing, will actually output a voltage. That's how it reads the resistance. So on this, it's outputting 2.7 volts from this meter to this one, because this one's reading my voltage. Fun fact, if you test a field coil and the resistance doesn't work, make sure the battery light isn't on your meter. I had a guy that cost him $5,000 because his battery was low in his meter. It was giving him a false reading going through. Now if I take my one lead and I add some resistance, still got 2.7. I got 45 ohms of resistance now in the circuit. Meter doesn't show it because I'm not running any current through it. I'm only looking at the voltage going through that circuit. So just because you have full system voltage in a circuit, doesn't mean that circuit can carry the current that is needed to go through it. Same thing happens when you're checking your starter cables. You go up, check your starter, yeah, I got 12.6. You know, should be fine. Load it. You're gonna load that circuit to see if it can carry that current going through.